All right, so interval of decrease would be where the roller coaster is going down, here shaded in the peak region. And the interval of increase would be the yellow region. How would we write our answer though? That's where a lot of people have trouble with. That's why we went over that interval inequality notation before, because this is literally an interval. And we're looking at, we would be decreasing from negative infinity to the vertex. And we're always going to use the x values. We're always going to use the x values for the intervals of increase and decrease. So from negative infinity to 1, my graph is decreasing. So how would we write that? From negative infinity to 1 with, I'm going to use parentheses. There's a big debate on whether we should use brackets or parentheses. A lot of things I see say we should use a bracket. A lot of other things I see say we should use parentheses. We're not going to argue over which one to use. Now, where would we increasing? At x equals 1, we would start increasing at x equals 1, and then we would continue to increase until we get way out here to positive infinity. So 1 to infinity would be our interval of increase. Now, if we were to flip that parabola upside down, literally the exact same parabola, but flipped upside down, the interval of increase and decrease are going to switch. My roller coaster would be going up the track on the left side of the vertex, and my roller coaster would be going down, or our graph would be decreasing on the right side of the vertex. If we want a mathematical definition for increasing and decreasing, like the one you might read on the front of your notes, it says something like, the function is increasing when the y values are getting larger from left to right. Always from left to right, the y values are getting bigger. So that's the definition for increase. And the definition for decrease would be just the opposite. From left to right, the y values are getting smaller. So in this case, our interval of increase would be x is less than 1 if we want to use inequality notation now. So we have negative infinity to 1. And we can use inequality notation as well to represent that interval. So all of the numbers less than 1. And what about our interval of decrease? It would be all of the numbers greater than 1. And we are using the x values for these. We are using the x value. So x is less than 1. We could write that as negative 1 to infinity. Or x is greater than 1 would be 1 to infinity. Either one. What are you going to see probably on like a quiz or test? Probably this notation, probably. But maybe the other one. You need to know both. You're expected to know both. All right, next graphs, we're going to label where these would be positive and negative. So if we go back and look at the definition says where the y values are positive, the graph would be positive, and where the y values are negative, the function would be negative. If we're using the roller coaster analogy still, we can assume that the graph is positive when the roller coaster is above ground, and the graph is negative when that roller coaster would actually go under ground. So where is the ground, you might ask? The ground is the x-axis. So that would be ground level. And when our roller coaster is above that, we would assume that the graph is positive. So I'm going to use blue in this case to represent our positive part of the graph. So in this case, all of that would be positive. We also have another positive interval because maybe this roller coaster went underground and came back up above the ground over here on the right side. So all of this over here would be positive. So that part of the graph would be positive. Well, where would the graph be negative? The roller coaster analogy says that the graph would be negative when this roller coaster is under the ground. And I'm gonna just shade inside this. Because if I start shading outside, it might get confusing, but that part of the graph would be negative in this case. So we have two positive intervals in this case and one negative interval. Remember when we did the inequalities a couple weeks ago, last week, I guess it was, and we did like the sign chart and we had the plus and the minus signs on there? We can do that for this as well. So from negative infinity to the x-intercept, which is -1 in this case, all of these y values would be positive. So we can literally draw the number line the same way we did last week when we did the inequalities. And from -1 to 3, all of those y values would be negative. Pick any y value you want. And that's why when we were testing points, we only needed to test one point in that interval. Because all of the numbers are going to be above the x-axis or below the x-axis. And then these numbers out here on the right are going to be positive. And how do we write those answers? Well, the same way you wrote them last week. We're looking for everything from -1 to the left. So that would be negative infinity to -1. Or everything to the right of 3 would be 3 comma infinity. Notice I did use parentheses this time, and we have to use parentheses this time. It's not a debate on whether I use parentheses or bracket. We have to use parentheses because the y value when x equals -1 is 0, and 0 is not a positive number. The same is true for 3. The y value when x equals 3 is 0, and 0 is not a positive number. So we cannot include the -1 and 3. So we are still using the x values here, but with the positive and negative intervals, we're using the x-intercepts. Where the intervals of increase and decrease, we're using the vertex. So the negative interval would be everything in between -1 and 3, but not -1 and not 3. So we use parentheses instead of brackets because we don't want it. We want it to be negative, and 0 is not a negative number. Now, if I flip this parabola upside down, guess what? The intervals of increase and decrease are now going to be the opposite. The inside of the parabola, inside the x-intercepts, is going to be the positive piece. That's where the graph would be positive. That's where the y values for the function would be positive. And then the negative is going to be this stuff on the outside. So to the right of 3, to the left of -1, those are going to be our negative values. In this case, our negative y values. So how would we write those? Literally just the opposite of what we did for the first one, but I'm going to do it in inequality notation, just so you can see that again. The positive interval in this case would be -1 is less than x is less than 3. Everything between -1 and 3. Everything between -1 and 3. And what about the negative intervals? This is going to be to the left of -1. So that would be x is less than -1. Or to the right of 3. So x is greater than 3. X is less than -1. Or x is greater than 3. We could also put those in the interval notation, which you would see here. Like this one would be that one would be that one. So they are switched. All right, cool. And we did label these things earlier, so you can label those. We've learned those before. All right. More time here? More time? We're good? All right, so I'm going to do the first graph. You're going to do the second one. We're going to skip domain and range right now. We'll come back to it because we haven't talked about those yet. We'll talk about those in a second. Let's find everything else that we've already talked about. The vertex. The vertex is the point at the tip of the graph, and that point has an x and a y value. So the x value is 1, and the y value is -8. That's just the point 1, -8. The axis of symmetry actually runs straight through that point. So the x values are equal. So x equals 1. The x-intercepts are where the graph crosses the x-axis. So 1, 2, graph crosses the x-axis in 2 places, -3 and +5. So we can write x equals -3 or -3, 0. And we can write x equals 5 or 5, 0. You can write either one of those. The y-intercept is where we cross the y-axis. And if we're not 100% sure, like right here, crosses the y-axis right there, and if we're not 100% sure that what that decimal is, we can't assume what that decimal is. So it looks like -7.5, but do we know for sure? How can I differentiate between -7.5 and -7.4 on my graph? We can't, right? So here's what we can do. We do know the equation, so we can plug in 0 for the x values in the equation for the y-intercept, and then that will verify. We don't have to type it in right now, but if you're doing this later and you're like, man, that's a decimal, I don't know exactly what that decimal is, we can plug 0 into the y-intercept, just like we did yesterday and the day before when we did graphing, and it will definitely show me that it is exactly -7.5. All right, the interval of increase. Where is our graph increasing? It's going to be from the vertex to the right would be where our graph is increasing. So that's going to be from x equals 1 to x equals infinity. So from 1, infinity is when this roller coaster would be going up from left to right. Our interval of decrease, well, this left side is where we're going to be decreasing, and we're going to be decreasing from -infinity to 1. So -infinity, 1. Where would the graph be? Positive above the x-axis, or negative, which is below the x-axis. Might not be a bad idea to color these like we did before. So our positive, I use blue. So positive with blue, and negative, I use green. I can erase this really quickly. You may not be able to erase it as quickly. But if you want to label something, that might not be a bad idea. Or if you just want to put the plus or minus signs on here. So plus, plus, minus in the middle, and then plus on the outside. That's not a bad idea either. So my positive interval is going to be from -infinity to the first x-intercept, which was -3. And then from the second intercept, which was 5, all the way to positive infinity. So -infinity to -3, or 5 to infinity. And our negative interval, where's the graph negative? Where is it below the x-axis? Where are the y values negative? From -3 to 5. From -3 to 5. All right, and there's 3 things on there we haven't filled out yet. You did these in Algebra 1, but we didn't really talk about them a whole bunch today. But what is the domain? The domain is all of the x values that might be included on the graph. Algebraically, it's the x values that we can plug into the equation and get a number back out, meaning like my calculator's not going to say domain error. Like I plug in a number, I hit enter, I get a number. I plug in a number, I hit enter, I get a number. So what are all of the possible x values that we can plug in and it actually work and not get domain error in the calculator? Looking at a graph, the domain is going to be the x values. The domain is going to be the x values from left to right. So think about like how far, like what is the smallest x value on the graph, which is going to be way over here on the left. What's the biggest x value on the graph, which is going to be way over here on the right, and are all the x values in the middle also included? So this graph is going up on both sides. But as that graph goes up, what's going to happen? That graph's getting wider. And how wide is it going to get? It's never going to stop getting wider. So negative infinity way over here, positive infinity way over here. Literally every single x value will be included on this graph. It's never going to stop going this way. For quadratics, it will always be like that. Even if it opens the opposite direction, it's still going to get wider as it goes down. What about the range? The range is the same idea, but instead of the x values, the range is the y values. And we can think about this as the bottom. We're going to start at the bottom and go to the top. So literally, what's the smallest y value on this graph? -8. -8 is the smallest, and -8 is included, so we're going to use a bracket. And literally, what is the biggest y value on the graph? We're going all the way up to the top now. Well, how far can we go? Well, we don't stop. We go all the way to infinity. So -8 to infinity. So when we think about the range would be the set of y values that we get out when we plug all these x values in. So plug any x value in you want into this equation, you'll never get a number smaller than -8. The number will be from -8 or bigger. All right, now, in behavior. The in behavior always confuses people because of the notation. As x goes to negative infinity, that is a negative infinity. Let's erase that and make it look like a negative infinity. So as x goes to negative infinity, y goes to blank. And as x goes to positive infinity, y goes to blank. So you're going to write that statement, both of those, every single time you do an in behavior problem. And the only thing that's going to change every single time you do the in behavior is what you put in the blank. So what does this even mean? As x goes to negative infinity. So let's think about x values, right? And we want x to equal negative infinity. That's going to be like way over to the left. So this right here is just a fancy way of saying the left side of the graph. So as we go further and further left, what are the y values doing? They're either getting bigger, smaller, or closer to a single number. And this right here, as x goes to positive infinity, is really just a fancy way of saying the right side of the graph. So as we go further and further to the right, what are the y values doing? If I go even further to the right, what are the y values going to do? So we can look at the graph, and the in behavior, the left in behavior is going to come from here, and the right in behavior is going to come from here. So as we go further and further to the left, what are the y values doing? They're getting bigger and bigger and bigger and bigger. And how big are they going to get? Well, they're going to get all the way up to infinity. And what about the right in behavior? Well, let's do the same thing. As we go further and further to the right, the y values are just going to keep getting bigger and bigger and bigger. And that's going to actually be infinity also. So when you do in behavior, the only thing that's going to change is what you would put in said box. The domain for any quadratic is going to be negative infinity to infinity. And you can also write that as all real numbers. So you may see it written that way at some point. The range. What is the minimum y value on the graph? Well, there really is no minimum because the graph's going to go down forever. So we're going to start at negative infinity. What's the maximum y value on the graph? Like we get to a point we can't go above. That is 8. And 8 gets a bracket because 8 is included on the graph. Like that point is on the graph. So we have to include it. The vertex is this point right here. 2, 8, 2, 8 is the vertex. If we know the vertex, we also know the axis of symmetry because the x values are the same. The x-intercepts, where does our graph cross the x-axis? 2 places, -2 and +6. So -2, 0 and +6, 0. Where does our graph cross the y-axis? Right here at +6. So 0, 6. In this case, this might be an example of like that blood in your bloodstream or the medicine in your bloodstream. When is the medicine in your bloodstream increasing, or the amount of medicine increasing? And that would be the left side of the graph here. So from negative infinity to 2, we are increasing. And then from 2 to infinity, positive infinity, because we're using the x value, we would be decreasing. So from negative infinity to 2, we are increasing. And from 2 to infinity, we are decreasing. Now, maybe we're talking about, we launched a rocket or something, and we want to know, when was that rocket above the ground? We launched the rocket from a bunker. So we watched this rocket from a bunker, like right here. When was the rocket above the ground? That would be the example of positive. When did the rocket go back below the ground, or when did it hit the ground? Would be the example of negative. So we're going to be positive in the middle, and then negative on the outside as it is. So from negative infinity to the x-intercept, -2. From -2 to 6 would be positive, and then from 6 to infinity would be negative. So positive was -2 to 6. Negative was negative infinity to -2, or 6 to infinity. And the end behavior. We're going to write the same two statements. Does this x piece, as x goes to infinity, all that means is the left side of the graph. And as x goes to positive infinity, all that means is the right side of the graph. So as we go further and further to the left, what are the y values doing? The y values are going down to negative infinity. And the right side is actually doing the same thing. So with quadratics, because the left and right side are always going to go the same direction, the end behavior for the left and right are both going to be the same, either positive infinity if it opens up, or negative infinity if the graph opens down.